All right, hey everyone. We're gonna just go through a quick little tutorial on assemblies and stuff like that. I got this part that we actually did a quick trial on before for some drawings and stuff like that. A couple weeks ago, or about actually a couple months ago now. One thing I'm going to show you first that I find super useful is the weld assistant. So if we have welded parts and stuff like that, you want to show that. The weld assistant's really great. You can do it by just adding on basically here, weld assistant by clicking on that. We're just gonna add a quick little weld with this guy. So simple, it's really easy, simple fillet. Go here, and it'll wave link it part because usually you do this in assembly, but that's totally okay. And then we do this one. Um, and then we should be able to see what happens. So that's really easy. Add a weld like that. I usually will just hide the, pardon me, the basically the wavelength parts and stuff like that. Actually, it's probably easiest to tie them here. Um, anyway, so we got a weld part. Going forward to an assembly, we'll just use this one thing to keep a note if you're doing weld parts and in an assembly, and that's why I wanted to show this. If you check your layers, for those who've been using them, Control L will open your layers tab. And bunch of stuff there, obviously. If you go layers with objects, you'll see that the weld layers are on basically the welded part that we need is on 255. That's going to be really important because otherwise you can't actually see that weld when you're doing this. Assemblies in a second here. Anyways, so I'm just going to save that quickly. We're going to jump into an assembly. So if you guys haven't done these before, sheet and drawing templates, you should be using these for creating your assemblies. If you need to, all you need to do is open NX, go to EV1, go to drawing or NX templates, and then you just need to open the drawing templates and the sheet template. So just click it here. I'm not going to do it because it'll double my thing up here. And then those two icons will show up. Just click on one of them each. You don't want to open them. You just want to, like, don't go NX file open, just open this and do that. Anyways, you guys have already done that, so we'll rip through. So drawing templates, click on a drawing template. In this case, I'm going to go with an A3 because I know it roughly fits this file size. It's going to open me up my drawing sheet. I delete this one. You should be able to import mask. We can go through that in a second, how to go about doing that. And either way, then it's gonna pop up with a view. I'm gonna close this one and I'll show you why in a second. But the first thing I typically do when I'm creating a new drawing is I will save it based off what the part number is supposed to be. So go up here, you'll see the default new created part and drawing assembly is, they'll just have this .dwg at the end of it. I will delete that and then add rd at the front. And that's all you need to do, but I'm gonna quickly, pardon me, add this in as a quick little test. I've been working through a few of these. So, all right, so now we have our brace part. There's a couple differences between assembly drawings and part drawings. And there's a couple things we'll need to be wary. So to start off with, you can actually, the front page, we'll probably use a couple pages here. You can start with something as simple as an isometric view to kind of show off your part, and then we'll add our balloons and our part numbers to show off which parts are in it. But I'm going to show you how to do an exploded view. So we can add one of these up here, but one thing you'll notice right away is that part is not showing everything, right? You can't actually see the weld symbol on that. So I'm going to show you how to work through that. So we'll close that. What we actually need to do at this part is we're going to go in our drawing part file. So not the original part file, but the drawing part file that we've created. See the tutorial part here. We're going to go applications. We're going to go to modeling application. And you see it's going to show up and it looks quite a bit different. It's just like a gray body. There's missing that. In this case, we can show the weld really easily if we go our Control L for our layers, and then we can quickly pop that layer on. Now it's going to show what we need to show, which is good. Okay, so next thing we got to do, we're going to do an exploded view. So doing that, there's a couple things we're going to have to keep in mind is you have to be in this view to do an exploded view. We're going to start off, go over here, sorry, pardon me, model views. We're going to add view, and we're just going to call this, we're going to rename this one exploded, and that should be good. Oh, pardon me, I added a space there. And then to actually explode your view, we're going to jump in here and go explosions. Explosions right down here. We're going to create a new explosion. Then we're going to go select all of our components here. And then we're going to jump to automatic. And then we're going to explode this part. And it sometimes will take a second depending on the computer and how big the part is. Sometimes pretty quick. So you can see now we've got all these kind of parts pulled apart to see it. On this part, it probably wasn't critical because you can see all the parts, but if you've got a lot of them, it's worth knowing how to do this. So one thing I've noticed, or you can see right here, is that we have parts that are kind of underneath there, and it might be easier. Like we want to pick a view to look at this at the drawing so it can show everything. And I kind of like having this a little bit more view. So if you want to adjust anything, you can go manual and deselect stuff. I'll just usually go apply. And then what you can do is swap it to manual, click on the part you want, click on the specify orientation, and then you can just move where you want. I'm going to do it about there because that kind of makes sense where it's going. And then I'm going to hit OK. Now we're going to see that it basically pulls us back to the explosion menu. One thing you can do, and is good practice, we're not going to be critical about them, but it's a good thing to do if you have a complicated part, you can add trace lines. So the way that works is you can select your parts really easily, and it'll start creating these like trace lines showing how it fits together. So on something like this guy, you can hit apply on that last one. You're going to see that we can do our trace lines. It's going to show a bit of a step jog, whatever you want to call it. And depending on the path one that you're using, they can have different trace lines. So in this case, we're going to apply that one. In this one, let's see, if we go about there, and then we can go probably, we'll go about something like that. So you can see on this case, you're going to get this weird around. If you want to swap that out, change it, see what kind of options it gives us. I mean, honestly, none of those are that great. What we could do is change our endpoint. So that's that one. This is this one. Maybe we can change it something like that. Maybe that makes more sense. So I can hit apply on that one. So now you can keep doing it for the rest of the parts if you'd like. Up to you. I'm not going to be critical about that. So now that we have our exploded view, you can hit close on this. You want to pick the view that you want it to show in the drawing. I think this sort of makes some pretty good sense here, something like that. I'm going to go to the exploded work view and I'm going to save that. Okay, that's all we really need to do in this part. Now we can go back to applications, modeling, or sorry, pardon me, applications, back to drafting. Now what happens, this is a really critical part, make sure you miss it. When we go to our base view, and you see if I go click on exploded, nothing happens, right? So why did that happen? We just created this view, everything's good. The issue is that the part itself, so if you come up to here, is actually we're using the reference part that we from the part file, not the assembly drawing file. So we actually need to go through here and you need to grab the drawing example assembly part. So this was the part file that we created. You can see this is the drawing assembly file, and it's the part that we created. Now if you click on this one and then I go explode, so now we got that. All right, so I'm just going to click that. I want to leave it scale 1:1, same as a sheet, even though I'm going to adjust that in a second here. Because remember, we never want to change that scale unless we want it separate from the sheet, because that won't adjust our sheet. So we're going to go to our sheet, right click, edit sheet. We're going to drop that down to custom, because 1 to 2 is going to be too small. So I'm going to go like 1.5 seems to be probably a pretty good range. If I do that, hit OK. There we go. So I'm pretty happy with that. So now the next part that's really critical for assemblies. I am going to we're going to do one other thing first. We're going to go and grab the main part you can see. So this is the part, the original part, not the assembly part that we're using. I'm going to go to an isometric view, and like normal, I'm going to pop this up in the corner to show kind of what it looks like there. That way you can actually see the weld and everything else on there and kind of what the part looks like. You might only need one of these two depending on the part, but this is just showing you how to do both. So then the next part is going to our parts list. So this is a bill of materials, BOM, commonly known. A couple things to go through. So we want to grab balloons. We want to show balloons. It's going to ask us which view we want them on. We want to go to the exploded view. That's correct. And then the next thing we're going to want to do, that should be good. And then specify location, we're going to pop this up in that corner. And you can see now our balloons have all showed up. Everything else is great. This one might be, kind of a weird position. If you ever want to adjust these, you can double click on the lines and then you can do specify location and you can move it to wherever the heck. Oh, pardon me. You don't want to specify location. You want to go, 1 second here. Terminating object is what we want here. And then I'll just move that balloon aside. Hard. It's there. Good. Specify location. I should be able to. Apparently today is being weird. We're gonna undo that one for a second here. So normally you should be able to drag if you want to double click on that. You can go select our terminating object right there. Perfect. So one thing to note though is we have 7 parts on here. And you can see that there's some weird stuff going on. It's like a duplicate, pointing to the same part twice, which you don't need to be doing. And you can see that we actually have the part name itself in here, which doesn't really make any sense because it's showing the assembly part. So to change that, if we ever want to double click on this, we don't want to go scope, we don't want to go all levels, we want to go leaves only. Now there's a time and a place that might be worth going top levels only. In this case, that's not going to make sense to us, but top levels only might make sense when you are doing basically an assembly that has a bunch of smaller assemblies in it, and you just want to show the assemblies. You don't want to show all the parts because each of those should be defined in their own part file, right? Yeah, so that's kind of where we're looking on this one. This front page, you can feel free to move it around, set up as you like. You can delete this box. When it's just for moving around and it's not getting in the way of dimensions, I'll leave it. But when I'm doing a lot of dimensions around it, I tend to hide it. I find it works easier. It gets deleted when you print the drawing anyway, so it's not a big deal. So we go to our fill in of the box here. You guys should all know how to do that by now. One thing to note is filling in our mask. If you haven't done your mask before, you need to go back to the part file. You'll need to grab the mask. So the easiest way to do that is go to the assembly, go to analysis, and then you're going to want to jump to show mask properties panel. That should be this one. And then update mask properties, and it's going to pop up. This is light this weight because I only put masks in a few parts, but we can copy this one. Oh boy. If you need to add parts to it, masks to it, you can do it here, but you're better off doing it in your individual assemblies or individual parts. That would be the preferred way to do it. So open up one of those, go to assign materials. We're going to pick steel, say in this case, 105. I'm going to select our body, hit OK, and then you can see that if we update our mask properties, this actually has a mask now, which is good. And then if we go back to this one, our main assembly, and we update our mask properties again, that should have updated. I don't think I saved that one. That's weird. Let's do show update mask properties. Either way, then you got to play around with that a little bit. I'm not going to spend time on that right now. And then we can go through, go to properties, and then enter in all the values and stuff like that for our name, title, mass, all that kind of stuff in here. For materials, you can just type NA, and make sure you hit enter before you hit apply. Not going to worry too much about the rest of the stuff. Make sure you fill out your drawings and titles correctly. You should be good to go, and then it should update between sheets. So that's what I'm going to do for the front page. It's pretty clear. It shows all the parts involved in it and everything else. Then we're going to jump back to here. We can update this. That's probably just from before. We're going to add another sheet. So we're going to go to our sheet templates, not the drawing templates. You want to go to the sheet templates. Grab the A3. Pretty simple. So now you can see here we've got 2 sheets set up in that workspace. Now we're going to do a base view because now in this one we're going to show a couple of things. I am going to do the front view first, I think. So we're going to pop this one here. And then I will do a top view up here. And I think that's realistically all I need from this one. Because what I'm going to show in this assembly, I'll do a couple things first. So first, I'm just going to kind of give the overall dimension of this part. Now, keep in mind, this is a reference dimension only. So I just want to click a reference dimension. It's not a dimension that's critical. These all should be measured in the part itself. I'm just trying to give a quick little scale of how big this part is. That's what I'm trying to do with that one, right? So somebody can see, okay, that's how big the part is. They're looking for parts of it or anything. They just kind of know the scale of it. What I am going to do though is I'm going to do a couple things here. One, I'm going to do because this is a slip pin, as you can see, if I jump back to the other sheet here, this is a pin that slides in there. We're going to make sure that we say how far down that goes, because unless you know how far down it goes, in this case, it doesn't go all the way, it doesn't sit flush, so I'm going to define that. I'll go back a sheet, I'm going to give a dimension right here, from here to here, and I'll pop that up there. And realistically, that's the only dimension I need in this one. But what I do also want to know is this welded area. I want to show people what exactly kind of weld that is or information. So to do that, you can do a couple things. One, if you haven't used a weld assistant like I showed you earlier, you can hide, this won't be here, but you are more than welcome to use a weld symbol, and you can just add this to any corner or anything like that. So if I thought I had a weld corner, I mean this down here, for example, if we thought we had a weld in there or something, we can do we could put a point in here or something, and we could say, look, we're welding in there. We're doing all kinds of stuff to it. So to next out of that, these are kind of all your weld features. You can go take a look at the standards and find out what they're using. A couple things to note. This kind of stands for all around. So if you had to weld around a circular thing or something like that, that's going to weld all the way around, which is useful for this one here. Actually, why don't we just do that one? Assuming I didn't use a weld assistant, I just put a feature there. I'm going to select this terminating object. I'm going to come over here, out of the way. I'm going to select all the way around because this weld goes all the way around that piece. And then one thing to note that's really important is when you're working on these weld symbols, the arrow side refers to the side the arrow is pointing on, and the other side refers to the opposite side. So if this was just a straight wall between here, and you wanted to weld on just the left-hand side, but if you wanted to weld on the right-hand side as well, you could just specify one side and put a fillet weld on both sides. So in this case, we're going to do a fillet weld, which is this guy. And then technically we could specify the length of the weld throat, which I don't remember what I did on this one, but I'll show you the easier way to do it. If you did use a weld assistant, we can go into here, we go auto weld symbols. This will just grab the information from this one. So we select view, we want to grab this one, and then we're going to select the object, which is this weld. And then we can hit apply, and it's just going to show up. So this basically gives us the throat of our weld. And because of where it's sitting, I'm not a big fan of that. So I'm just going to double click that and change the terminating position to right where that one is. I like that one better. I'll delete that leader. And that's all the information I need. I'm going to delete this other one, and I'm happy with that. Like that should work. So now I've got the height of this, I've got the welding of that. A couple things, obviously, is that's a slip fit pin. We're also going to want to specify the radial orientation of this. So I want this 90 degrees to that back face. You can pick whatever face you want it measured to. In this case, I think that back face was one of our datums, but for our assembly, maybe it would make more sense to use the space between these parts. That's kind of up to you as a designer. One other thing to note is there is a bunch of bolts on here. As making basically any kind of assembly, if you're assembling with bolts, you should be specifying a torque value on these, right? For engineers, that's our job to do that kind of stuff. So there's a couple ways we can do that. One, we can just add a note, simple plain note, and say torque to say 200 Newton meters. That's totally fine. Now, one thing I should add, because there's actually 4 bolts, It might be not a bad idea to add another view here, but I'm not going to worry about it right now. So I'm just going to add a 4 times in here. And then I'm going to select the terminating object. It's going to be this guy here. Torque to basically that. Basically, that's saying that all those bolts should be torqued to 400 Newton meters or 200 Newton meters. The other way to do it, and another important way to do this as well, is we should be going to our we're just going to do this. We're going to go to drawing guidelines. In the bottom, we got to add notes for this one. So notes. This is a welded part. So there's a bunch of. I think that might have gotten deleted here. Why did that happen? I think I might actually delete that by accident. One sec. Okay, we'll just grab this, control copy. And then we're going to go back. I'll deal with that later. So now that we have the welded notes, we're just going to pop that in there. And we're going to go through and figure out what we kind of need. So remove sharp errors and edges. That's good. Stand for engraved part numbers. That's good. Delete these double dots. I don't know why they're there. Spell, spatter and clean. That's important for welding. Depends on the process, but it's not a big deal. So this would be specifying type of wire you want to use. In our case, ER70S-6 is good for steel because this is a steel weld. This is the standard that we use to interpret the welds. Pre and post heat treat, I'm not too worried about. If you're using high carbon steel, then you'd want to consider that. And then, oh boy, one of these days I'll get this right. That heat treat, don't care about that one, but I'll leave that open for a second. Material, not going to worry about that because we've already specified it in the part dimensions and they're not all the same. Finish, painted. We're going to go painted. You can go use your analysis to find the surface area, but it's not always critical. It's a good thing to do, but not totally required. And then I'm just going to go blue. If you have requirements for paint or shade or anything, that'd be worth doing. So we're going to throw that down here. And obviously I want to make sure these are clear and easy to read. So I'm going to move stuff. Then what I'm going to do in this case is I am going to, the second option we can do for bolts is we can do a note here. If you have a bunch of bolts all over the place, and they're all the exact same, we can just go select all this, C note 6, and then we're going to go select our terminating objects. I'm just going to pop it off one of these, and that should be fine. And now you can see, so we got C note 6. This would be the other way you could do it. It'd be one or, you don't want to do both. And then in this guy, we would go say we'll just do this one a little bit different. We'll go 300 Newton meters. And I don't need to have that double thing. So this would be good. Now that kind of clarifies that our bolts should be torqued to 300 Newton meters. If you had a bunch of bolts with different varying things, you could just say, add a table in here, specify your table, and donate the part name or the type of bolt. Those are all totally valid options, depending on how many you want to do it, making it look clean and precise. One other thing we should note, I think there's some other dimensions I meant to do. In this case, there's a couple things we need to do. We need to give the dimension of this one because that's part of our assembly features, and the dimension for this key here because that, again, is also one of our assembly features. So those are both part dimensions that are needed to be specified for this assembly to go back to the way it was intended or as us, the designer, wanted it to go. I hope that sort of helped, gave everyone kind of an overview on how to do this. It's kind of a weird part. It doesn't really have any purpose, but as you can see now, we've got 2 sheets, one that shows the breakdown of this. If it was a really simple part, maybe you could have just done it with one view here. You could have put the all of the bubbles on this one. So for example, we could have just added, let's see, we could add the bubbles on, oh, pardon me, that's not what I meant to do. Okay, there. So we could do bubbles, show this one. So if I wanted to put the bubbles on this one, I could do that too. Um, that might be totally fair. This would be another way to do it. And then I could put those views that I talked about in here and show it all on one page. So it really depends on how much information is there, how much information you want to get across. This is probably all we really need. We probably don't need this exploded view, but that depends on you and how critical you want to be and where you want things to go. So yeah, if you got any questions, always feel free to give me a shout and let me know if I'm missing anything. Fantastic.